lesson 3.6 will be a nice, I don't know, reprieve maybe, a break from logs, or at least to an extent. I guess we will use logs a little bit to solve, but generally this is our mathematics of finance. You, over the years, have done various, used various formulas to find interest and stuff. That's what we're reviewing today, okay? So, we're going to start with a more basic formula. I guess the basic formula is simple interest, but we're not doing simple interest. We're going to start with compound interest. So, we have a formula for interest compounded annually, and this formula specifically works when the interest is compounded annually. Annually being how often? Once a year. Okay? Now, as with most of the equations we look at today, P is the principal amount, so the amount invested, the starting amount, the amount deposited, whatever. R is the interest rate. Of course, when we're working in an equation, we use R as a decimal. A is the amount of investment. So A is the total amount of investment, what that original amount grows to after N years. Okay, so this particular book uses N. I believe it uses N for their exponent. Okay, so this is specifically when interest is compounded annually. So let's look at example 1. Suppose Quan Lee invests $500 at 7% interest compounded annually. Find the value of her investment after 10 years. What do you know? Okay, so she invests $500, so we know that P is 500. What else do we know? Okay, 7% interest as a decimal. We're going to use that as 0.07. What else? Okay, 10 years. So that's our amount of time. So N is 10. And always check, because they're going to be mixed up in homework to an extent. How often is this compounded? Annually. And the fact that it's compounded annually basically tells me that I can use that formula up there. Fair enough? So we're going to use the formula A equals P times 1 plus R to the N. We're trying to find the value of our investments. We're trying to find A. P is 500. 1 plus, for R you're putting in the decimal, 0.07 raised to the N, which is 10th. Now, there's about one thing you can clean up and do by hand, right? And that is inside the parentheses, 1 plus 0.07 is going to be 1.07. So I have 500 times 1.07 to the 10th. And now comes calculator time, right? When you guys were on scientific calculators, I would have said do your exponent first and then multiply by 500. On these calculators, am I guessing you just entered it all at once?
Yeah.
Okay, fair enough. What did we get?
5.
938.58?
980. I got 980.
Oh yeah, 83, not 30.
Oh, wait, what do you have?
983.
Yeah,
58
I
cents.
got 9. Me too. That's mine.
Yeah.
So I became dyslexic when I wrote my notes down, is what you're saying.
Yes.
Is that what you're trying to tell me? Because in my notes, I have 938.58.
It happened.
Okay.
83. 58.
Okay.
It happens to the best of us.
983.58.
58.
Okay. Are we good?
Yep.
Yes.
Okay. What label am I putting on that?
Monday.
It is money.
We can listen.
So this is $983.58.
Have we done this before? Yes.
Oh, yeah. Okay. So that is our one example that we used. And again, that was just basic compounding annually. Okay, that's your basic compound interest formula. Now, as you look next, there is another formula. This time it's interest compounded K times a year. Okay, as in, is interest always compounded annually and once a year? No. Okay, it's sometimes compounded more. So this formula, the slight difference is that we have a K value included. A equals P times 1 plus R over K raised to the KT. P is still your principal. R is still your interest rate as a decimal. K is the number of times per year. So K relates to how often is this compounded. Okay? When we get to that example, yes. Okay? A is the amount of investment after T years. So, suppose Roberto invests $500 at 9% annual interest compounded monthly. Find the value of his investment after 5 years. So what can you identify for me? Okay. P is the 500, R is the 9%, 0.09. K is 12 because how often are we compounding? Monthly. And how many months are in a year? 12. Okay. And then T is 5. And the question is find the value of his investment, so find A. So we are using the provided equation. A equals P times 1 plus R over K to the KT. So A equals 500 times 1 plus 0.09 divided by 12 raised to 12 times 5. Okay, there's me setting the steps out, writing the steps out. Okay, could you enter it on your calculator exactly in this form? You can. Okay, could you clean it up a little bit before you enter it on your calculator? You can. Your choice. So, what is inside those parentheses? 0.09 divided by 12. Did anyone do that one? Okay, so 0.0075. So then we add that to 1, we're going to have 1.0075. And then raised to the power, 12 times 5 is 60. Okay, that's a slightly cleaned up version if that's easier to enter into your calculator. Now, why did I want the calculators at your desk? Because I want you practicing, right? Make sure, get the goofy mistakes of how you're entering these out of your system now. Okay, what did we get?
$782.84.
$782.84. Notice it is automatic. We're rounding to 2 decimal places today, aren't we? Okay. Are we good with that one? Well, ready for the next one then? Okay. Judy has $500 to invest at 9% annual interest compounded monthly. How long will it take for her investment to grow to $3,000? So again, let's write down what we know. Okay. Starting amount, $500. So P is 500. Okay. 9%. So R is 0.09. Compounded monthly says K is 12. How long will it take for her investment to grow? So I'm looking for T. And then the 3,000 is what we want that investment to become. So A is 3,000. And this was where this lesson becomes pre-calc lesson instead of like a basic algebra lesson. Okay? So, fill in your equation, right? So, A equals P times 1 plus R over K to the KT. What do we have? 3,000 equals 500 times 1 plus 0.09 divided by 12 raised to the 12 times t. Okay. Let's do a little bit of cleanup before we discuss how we're going to proceed. Okay. So 3,000 equals 500. 1 plus that 0.09 divided by 12 is 1.0075. And it's raised to the power of 12t. Okay. Thoughts here? Okay. I would encourage you to divide the 500 away from our power. And that's actually going to be a required step before we can take the big step, okay? Is that we want that power to be by itself. So I want that 1.0075 raised to 12t to be isolated and by itself. So to get rid of the times 500, we're going to divide 500. 3,000 divided by 500 is 6. So now I have 6 equals 1.0075 raised to the 12t. Yeah, does this look like something from last night's homework? Okay. We have two different bases. We're not going to get the bases the same, so we're going to take the log of both sides. So I'm going to have log of 6 equals log of 1.0075 raised to the 12t. Okay? What's my next step? Okay. Use our power property. Is this sounding familiar?
Yeah.
Okay. So log of 6 is equal to 12t times log of 1.0075.
Would you divide log 6 by log 1.0075?
And
12. Okay.
so you can, yeah, now we have to be careful how we enter on the calculator, but here's the deal, guys. On this right side, I have 12 times t times log of 1.0075, yes? Multiplication is holding all three pieces together. How do we undo multiplication? Divide. So we're going to divide by 12 log 1.0075. Okay? So I'm going to divide the left by 12 log 1.0075. And what's going to happen then is that allows the 12 to cancel and the log to cancel. So at this point it becomes a calculator deal, right? It's log of 6 divided by 12 log 1.0075. My recommendation on this type of stuff is always just use a fraction bar on your calculator. However, if you're not using a fraction bar, you must put parentheses around this denominator in this situation or it won't work right. Okay?
$19.983 years.
Did you guys get the same answer?
Yeah.
I have 19.98 ... written down on my paper. Now, I do have that rounded. And I don't know what directions will say, but I have that rounded to be approximately 20 years. Okay. Am I saying that I'm going to count 19.98 wrong? I am not.
I thought there was no packet, I feel like. Really? Yeah, we did.
It is a quicker chapter. An unusually quick chapter compared to chapters 1 and 2, which were forever long. Chapter 3 is a nice little break. I mean, yes, there's there's a lot to learn with logs, but there's definitely a nice little break here. Okay, are we ready for the backside?
Yeah.
Okay. As I said, I'm opting not to do the bottom section, exponential growth and decay, based on what I assigned in the homework and just everything else. I'm opting to not to do that one. So, okay. Example 4. Stephen has $500 to invest. What annual interest rate, compounded quarterly, is required to double his money in 10 years? Okay. What information do you have? Okay. Starting with 500, so P is 500. Okay. Compounded quarterly. How many times a year is quarterly? Something happens quarterly, that happens 4 times a year.
T is 10.
Okay. 10 years. T is 10.
K is 1,000.
I don't see a 1,000 in this problem. But she's telling me A is 1,000.
That makes double it.
Are we seeing this? What is required to double his money? What's he starting with? 500. So what's he trying to grow to? He's trying to grow to 1,000. Good catch. That's the tricky part of this problem, isn't it?
Yeah.
Okay, or at least a tricky part. And then what are we looking for? We're looking for R. Okay. Set it up if you haven't already. A equals P times 1 plus R over K raised to the KT. Okay, what did we say? A is 1,000. P is 500. 1 plus R over 4 raised to the 4 times 10? 40. Okay. Well, thoughts here? Yes, I'll clean up 4 times 10 is 40 here in a moment. But what actual step could I take?
Divide over 1,000? Or 500?
I say divide the other way. Okay. Work to get this power isolated to figure out what we're going to have to do next. So similar to the last problem, we're going to divide over the 500. 1,000 divided by 500 is 2. 500s cancel. I have 1 plus R to the 4th raised to the 40th.
Do you possibly subtract the 1? Or is it all be?
I cannot touch the 1 because it's in the parentheses that are being raised to the 40th power.
Can you 40th root both sides?
You laugh,
Oh my gosh, that's actually.
but you can't.
Oh my gosh.
Okay. If that was a power of 2 or a power of 3, what would we do? We would take the square root, the cube root. Do you have a fancy calculator? Well, shoot, even your scientific calculators from Algebra 2, could they do a 40th root? Yeah, you have an option to type a root in. So we're going to get rid of that power of 40, we're going to do the 40th root. What you do to one side, you do to the other side. Now, I'm not going to actually, we can do 40th root here in a moment. Let's work to finish getting it solved. Okay? As in, okay, the 40th root of 2, for the moment, I'm going to leave the 40th root of 2 as 40th root of 2. On the right, when I take the 40th root of that 40th power, I'm left with 1 plus r over 4. Finish solving for r with me. Subtract the 1 over. So then I'm going to have the 40th root of 2 minus the 1 equals r divided by 4. If it's r divided by 4, we're going to multiply by 4. So when I write this out for what I'm going to put in the computer, the calculator, r is going to be, and I'm just going to do 4 times parentheses, the 40th root of 2 minus 1. Does that make sense? Okay, did you find a place to do 40th root? I'm trying to think if it's up in the alpha shortcut menu or not. It's in the math menu if all else fails. Up in alpha F2, number 6 is the x root. So you can get it from alpha F2. It's number 6. Or you can go in the math menu. Just hit math and it's number 5. Are you finding it in one of those places or should I put it on the screen? Okay. So alpha F2 shortcut menu, it's number 6. Math menu, it's number 5. You're going to be typing in the 4 times the 40th root of 2 minus 1. I don't know, maybe I should have put my calculator on the screen, but you guys seem to have been coping all right.
Yeah.
What's the calculator telling us?
0.070.
What'd you say?
0.070.
Are you rounding that?
Yeah.
Give me a little bit more before you round it.
0.0699187.
I have written on my paper 0.0699 ... because here's the deal. We're looking for R. What annual interest rate? What should I give that as an actual answer?
7%.
Yeah, I have 6.99% written down. But in other words, 0.06, this is the decimal form, so as an actual percent, 6.99% or 7%. Okay? Okay. Got one more for us. We're going to have some time to check homework after all. Okay. One more formula, and that is our interest compounded how often? Continuously. So this formula is similar in that you see the P, but then it's times e to the RT. Okay? Or I often say A equals PERT when I'm, trying to remember it. But P is still the principal amount, so the amount you start with. R is still the interest rate as a decimal. A is the amount of investment you're going to have after T years. And what's E? E is that base E, that 2.718 number, okay? That is a button on our calculator. Now, example 5. Suppose Latasha invests $1,000 at 8% annual interest rate, compounded continuously. Find the value of her investment at the end of the years 1, 2, ... 7. Now, what do you know? Gather information with me. What do you know?
P is 100.
Okay. Starting with 100. P is 100. What else?
R is 0.08.
Okay, 8%. So R is 0.08.
T is 1%.
Okay, T is 1 through 7. Okay. And I'm going to remind you of a way you can shortcut that so you don't have to type it into your calculator 7 times if you want. How often is it compounded? Continuously. So what's that tell me? That's not a number, but it tells me to use what formula? A equals P times e to the RT, or PERT. See, you can remember it that way, can't you? Okay, so that's what the continuously says in my brain. Find the value of her investment, which means we're finding A, not just once, not just twice, but 7 times.
Nice.
Now, if we write a formula that represents this situation, so A equals PERT, what's the formula that represents this situation? A equals 100 e to the 0.08, and I'm just going to say times t for right now, yes, because we have multiple different t's. Now, we are wanting to do 7 answers. Can you do 7 answers on your calculator? Can you copy from the row above and just change that number every time? You can. Do you guys remember using our list by going into stat? You can get all 7 answers at once, and if you know how to use it, it does go pretty quick. As in L1, I would put my time. So I would put my 1, 2, 3, 4, 5, 6, 7. Yeesh. Okay. In L2, we're going to type our formula. What's our formula? 100 e to the 0.08. Now, what do I say instead of times t? Where are my t values? In L1. So this is going to be times L1. And then that will give you your 7 answers. Now, this one I will put on the calculator, or up on the screen. Let's see, what do I need? I need to flip off of that screen to that screen. Stat.
Yes.
I use this calculator because I know. What's going on? Turn the elbow on today. Okay, there we go. So, if you go in using stat, and then I just go into edit, which is number 1. My lists are actually cleared. Oh, because I just updated my calculator the other day. To remember, if you need to clear it, do not delete a column. Go up, if you want to go up into the heading and clear the whole column, do clear enter while you're up in the heading. So if I do clear enter right there, it clears out all the numbers in a column. In L1, I am entering my years. 1, 2, 3, 4, 5, 6, 7. And then in L2, if you want to enter a formula, you go up into the heading. So I'm up there where it says L2 equals. We're going to type in our formula. 100 e, which is the second function of the natural log button, e to the 0.08 times L1, which L1 is the second function of 1. My formula looks like that. When I hit enter, I'm going to have 7 answers. Good? Now, do you have to use that method? Absolutely not. I don't know if you like it or not, but those are so at the end of the first year, the value of her investment is $108.33 at the end of year 2. $117.35. 127.12, 137.71, 149.18, 161.61, and 175.07.
Oh.
So, if you have an error, I'm going with something got entered wrong in your formula. Is that your normal multiplication sign?
Yeah, I did it without.
Wrong value or variable type in. Attempted to store number 2 go to. No, because it was showing me, I just can't figure out. Did you use this L1?
Yeah.
So, what if I take out the parentheses? It shouldn't matter. I don't know what, no. Oh, now I just lost it altogether. Okay, type it back in. I don't know. I'm not 100% sure where.
Oh, it's because I was trying to do the first column.
Oh, you were in the first box. Okay, there we go. And I wasn't catching that, obviously. Okay, yeah, you have to type it up in the formula box. Okay, guys, your homework for this lesson is page 304, 1 through 12 all, 22 through 28 even. That homework will be due on Friday because I'm not here tomorrow.